Hello, and welcome to the Boffin Buzz, the podcast for anyone fascinated by farming's future. Well, hello, and welcome again to the Boffin Buzz, and exciting news this time because you can get CPD points from listening to the Boffin Buzz, and this week's episode is divided into two parts, and you need to listen to both parts in order to claim your basis points. So, somewhere, I'm not going to tell you where, within this episode, I'm going to tell you the first half of the code that you will need, and then in the second episode, you'll get the other code. And if you put the two together and email us at info@boffin.org.uk, you can receive your basis point for this particular episode of the Boffin Buzz. So that's right. Professional points for listening to this podcast. And not only that, we're going to be looking at the world of AI and autonomy and robots today. And I'm delighted to be introducing two new partners for one of our projects, the Slimers projects, strategies leading to improved management and enhance resilience against slugs. So, first of all, Charles Vase is Managing Director of Photonix, which he co-founded in 2018, I believe, with the mission to develop out the boundaries of modern food production. We will be finding out what that means in a bit. So this is all about using cameras and AI, and we'll hear more about what we can do with those in farming in a bit. And we're also joined by Callum Chalmers, who is Director of FarmScan Ag, which creates high-efficiency farming technology. Now, originally from Brisbane, Australia, Callum spent 4 years as a software engineer for FarmScan before heading to the UK in 2016 to launch and develop FarmScan business here. So since then, he's taken on a key role in the Hands-Free Hectare project at Harper Adams, and we'll talk a bit more about that in a minute. But so welcome to you both. Thank you very much for joining us, Callum and Charles.
Yeah, thanks for having us on.
Now, first of all, before we sort of delve into the tech, I'm really sort of keen to get to know you better. So, Charles, if I can turn to you first, just give us a little bit of a background, where you came from and how you came to be working, in agri-tech.
Yeah, sure. So thanks, Tom. Well, firstly, thanks for having us on. And my background started off as an engineer, actually, so machine vision engineer, and anything you could point a camera at to automate sort of decisions or measurements, and that was kind of my focus. And about just over 10 years ago now, I got sort of asked to join a project with Syngenta and G's Fresh that was about looking at identifying weeds. It was basically green on green, people could call it, and that was kind of the first bite I got into the sector. And I think I was converted from then. It was quite enlightening. I didn't, at the time I thought very much ignorantly that farming was very much, Wellington boots and pitchforks, not forgetting how much technology, automation, mechanization, the size of the companies, I think was just eye-opening and quite awe-inspiring. So that was sort of the beginning of the end, and I'm still here now. We're growing. We started one down, and we're 12 strong. So it's been a good experience, highs and lows, but excited.
So
excited.
Your background isn't in farming at all. You
No, not at all. I very much came from a diagnostics point of view, versus imaging and that side, and looking to sort of apply that. I think agriculture's got a lot of opportunity. It's kind of been left behind by some sectors, and not for any fault of its own. It's a very difficult sector to operate margin-wise. A lot of big companies have sort of avoided deploying in there. So I think it's an area. For me, the big mix is the mix of the use of technology, but also the impact of it, the sort of the social impact. Food systems is critical, so it's quite a nice balance to be able to be doing that inside the food environment rather than different sectors that might not be as sort of rewarding.
No, absolutely. We'll explore that in a bit, I think. But moving on to Callum again, could you give us a little bit about your background Callum, and how you got into agritech.
Oh, yeah, definitely. So my story's pretty similar to Charles, albeit on the other side of the world. I don't come from a farming background, but I got into it through my family. So I'm an engineer by trade. I did mechatronics engineering, which is kind of like robotics in Australia. I ended up doing an internship at the company where I did a bit of software development and things like that. And then, yeah, didn't think I'd like farming at all, but ended up really interested in the challenges that they face and sort of what they have to do with the resources they've got. That was
Right.
really impressive. And I think, there's not that many industries where they have so many challenges, even just dealing with the weather. And so anything we could do to sort of help that and, what they could benefit from a technology perspective actually became really interesting to me. And the rest is sort of history now. So, yeah.
Yeah. Now, as I said in the intro, you worked for a bit on the Hands-Free Hectare project, which then became the Hands-Free Farm, I think. And just for those, for those listeners who aren't aware of the project, would you like to just give a little bit of background about what the project was?
Yeah, so the hands-free hectare was the original one, and that was to grow 1 hectare completely autonomously. So for the whole project, nobody went into the field whatsoever, and they used all commercially available open source software. And I believe they were the first people in the world, as far as we know, to actually do that. From there, that's where we came into the picture, and we started the Hands-Free Farm, which was slightly more ambitious. We came on as a technology partner, really looking to try and give it a more commercial approach. And we went from 1 hectare to 35 hectares. We went from sort of one vehicle to multiple vehicles working simultaneously, really trying to build it up. And the whole goal was to use small vehicles, but actually try and do this in a commercial farming sense rather than sort of a very simplistic build a product, test it. Yep, that's good. We wanted to show this working in an actual farming environment.
Great. Well, we can talk through some of the challenges that you found and that you're dealing with at the moment a bit later on. But if I can come back to you, Charles. Now, one area that you're particularly focused on is the world of AI, as I said in the intro. When I say AI, of course, I mean artificial intelligence, not artificial insemination. Just, I mean, it's something that we do hear a lot about, some good news, some bad news or whatever. Could you just, if we can go right back to basics, could you just explain what is?
Yeah, no, sure. I mean, well, that's a very good question, and probably one that's definition has evolved over the years. I think that the real sort of definition we always go back to is it's just automation of a task that would typically be considered human. And that's fundamentally what it is. What it's become technology-wise has evolved massively. When I started, it was just basic software. Now it's becoming more and more capable. I think the only real discernment people understand is you get very specific AI, for the sort of weak AI that's for one specific process. So it could be converting the words that I'm saying now into text. So most people's phones or devices now do that, voice control. And then you get more general ones. So lots of call centers now, or customer service, you call them up, they can be conversational, they generate more sort of words, and then sort of what you're hearing a lot more about now. And both have uses. I think in agriculture, what we're really thinking about is how can we save time for producers, because time is really crucial in either not adding time. This isn't about inputting more information or inputting more data. This is about triaging, waking up early in the morning and getting a list of what are the key tasks based on what all the large amounts of sources, of data sources that you've had. That's really the focus of AI, and we can call it software or we can call it what you want. But I think it's certainly seeing a wave of excitement. I'm hoping it will deliver on that in some of the areas. But yeah, we typically don't use the term as much, but I understand from outside of the sort of tech world, it becomes a lot more sort of exciting and new.
Yeah, I mean, I guess in agriculture, what we're talking about here is sort of automatic identification of things. All of us as farmers and operators within the industry, we are, every day when we walk through our fields, we're spotting weeds, you're observing things, and so on, perhaps listening to birds or whatever, and things. And I guess the role of AI there is to document it and to capture it and to locate it and things, and do that automatically. And I guess that ties in with the camera side of what you do. Am I along the right sort of lines here, Charles?
Yeah, I mean, I think that that's spot on. It's really basically, data entry tasks are quite things that people are good at, but they're very slow. They never really, they won't compete at the same level, and very variable. You want a fun game, give different scoring charts to five of the sort of your farm workers and see how consistent they are. It's very very different. Different lighting, different times of day, how hungry someone is. It all changes how they perceive something, and actually that's not helpful in what is already quite a variable, very dynamic climate. So yeah, it's very much a way of, I think it displaces a lot of the tasks. So it tries to remove a lot of the tasks that don't require the kind of the insight and the experience of the farming does, and more informs them. So it kind of gives you a list of what it's seen of metrics, and then you have to sort of absorb those and decide what to do next with that information. I don't think that's going to be automated for some time, if ever.
Right. Yeah. So it's not about making decisions. It's just about, sort of finding things and locating it, really. Is that right?
Yeah, you can advise decisions based on past actions, but there's such a dynamic climate, what's happening, what geopolitically, what's happening in the market prices, so many things that you can be advised. I mean, I take a lot of my sort of inspiration from the medical sector that adopted this technology sort of 10, 20 years ago. It didn't displace or replace consultants that were looking for scans of people in sort of MRIs. It more informed them so that they could look at 20 rather than 10 in the sort of half an hour period they had to do that. It's all about improving the labor efficiency, because that's what's expensive at the end of the time. That's really the core cost that this type of technology is looking to sort of optimize, or at least improve the impact of.
Yeah. So moving on to some of the projects that you've worked on in the past, Charles, can you just give us an idea of So I mean, you mentioned earlier on this work that you've done with Syngenta and G's. Perhaps could you give us a little bit more information about that?
Yeah, sure. And I believe that was some of the earlier parts of the sort of Hands-Free Farm. The team from Harper were also in that. So that was just
All right.
a project that was looking at, I think there was a combination of lasers, there was spot spraying, there was new formulations. It was kind of going past just in lettuce crops, being able to get inter-row crops and look at infra-row crops, so that you could actually get ones that would be in sort of, let's say, similar rows as the material you don't want to hit. And my input into that was more just providing a camera that could tell the difference between weeds and crop that were the same color. Things that are different color or look different can help out. But I've it's been a long time, and many a projects. We kind of, a lot of the work commercially that we do started off with breeders, so glass houses, much more confined environment, and it's more recently we've gone back to where I kind of started, which was arable. It's a really exciting area, but it doesn't always have the right kind of technology for us, because we're really about providing insight, and it's great to find out information, but if you can't do anything about it, then so what? And that's the hard thing about arable is, yeah, we can find something, we can show you where it is, but are you going to do anything about it? Because sometimes you won't. It's just not viable or feasible. So I think we have to kind of wait, or step forward with the industry and with other industrial partners to say, oh, well, now there is the technology, now there is the financial viability to actually act on that, then we can provide that information, because we're not in the industry of generating information. It's about insight, and if you're just showing maps of things, well, that's helpful for nobody. So it's an interesting one, and I think
Yeah.
the projects that are being supported, a lot of them by UKRI in this country, are kind of world leading in its sector, and the kind of the culture that it generates. But I think there's also a bit of a chasm between the ones that are developed as part of a project and the ones that are taken forward commercially, and that's
Right.
definitely something that the sector's really trying to work on, is improving that conversion rate of, well, that was a really good multi-million-pound project with some great partners, to, yes, well, that needs to turn into a multi-million-dollar industry, or service provision, like an export.
Yeah, no, absolutely. I'm sure we can explore that further. But if I can turn to you, Callum, and let's return to the hands-free hectare project, and this sort of whole realm of autonomy. I mean, so basically, what we're talking about is the driverless tractor, the driverless vehicle around the farm, and so on. I mean, what are the key challenges, the key technical challenges that you face in your line of work?
Yeah, there's no shortage of them, and that's kind of one of the key problems. We wanted to, our focus was really on utilizing equipment that people could readily purchase and they had in the farm. What we didn't want to do is not so much reinvent the wheel, but there's challenges associated with alternative power source, all these sort of custom robots that are coming out. We wanted to focus on, one of the sayings is that, tractors almost drive themselves these days. Well, our sort of vision was, well, why can't we do that? Why can't we make this autonomous system something that's compatible with the existing farming ecosystem?
Right.
And so to do that, we had to take what was conventionally available and convert them to autonomous systems. So the platform that we developed is designed to integrate directly with existing machinery. So it didn't require people to purchase a brand new machine that was £200,000 or something that was very specific. They could use something that they had lying around if they had a spare tractor, and they could convert it. And the challenges to do with that was it was automating all the things that we take for granted, things like sight, what's in front of the vehicle, what's around it, and then even things that you do very easily. Tractors steer themselves, but they don't accelerate and slow down by themselves. So for us, we had to convert things that were done by a human into a kit that we could put onto these vehicles to manage that. So actually being able to stop when we wanted to and control the speed, which is all taken for granted when you just put your foot down and you go faster, but there's actually not an electronic control in existing tractors.
Right. I see. So it's about adapting. As you say, a lot of tractors these days drive themselves. And with auto steer and things. Once you get it into the field, it's going up and down. You hardly need to be there. I would suspect that there are an awful lot of listeners who spend quite a lot of their time when they're driving up and down on the field on Twitter or X or whatever and things. Anyway, I don't know whether you're supposed to be doing that, but we're nearly there. If you think about the difficulties of driving on the road autonomously as opposed to driving in the field, I would imagine that there's less hazards, less dangers, less barriers in the field than there are on the road. Is that right? Are we sort of further along the way to the autonomous tractor in the field, or are there extra things in the field that that aren't encountered on the road that make it a more difficult prospect?
Yeah, I think it has its own challenges, 100%. But compared to driving on the road, one thing that most farmers aren't subject to is other motorists in their field, which is, that's a good problem to have realistically. Often you're in the field by yourself, but you're not always by yourself, and that's the safety consideration that we need to take into account. And frequently, if in England, they have shared pathways, shared access ways. And how do we operate safely in those areas? So, most vehicles these days will have LiDARs on them. They do have to have safety systems that take into account people in these fields or animals. It's the kind of things that you take for granted with your vision. A lot of the crops that we're working in as well, they're not, the height of the crops means you can't actually see through them. So it's a good opportunity to test things like radar and things that can penetrate through the crops and potentially even provide a safer operating condition that you wouldn't have had previously. So there are advantages, and I think compared to having to work on the roads, off-road is definitely an easier solution in terms of the working with other vehicles. But that doesn't mean that it's simple, and there are other things to account for with changing terrains, gates, lakes, all the kind of things that roads don't tend to drive into that are quite common in fields, isn't it?
So just thinking about that, one of the things you've highlighted there, Callum, is that actually, autonomous vehicles can probably do a better job in the field in some respect than operators. I hope I'm not alienating myself from too many of our listeners by saying that. But just to give you an example, we had on the farm here a couple of years ago, we had quite a worrying incident, actually, when someone drove into a telegraph pole in the middle of a field, and literally the telegraph pole snapped and the lines came down. He was very fortunate to get out of the vehicle without, obviously injuring himself. But that just gives an illustration of the people aren't infallible in terms of driving the vehicles. And you also highlighted another aspect of that in terms of LiDAR and all these other technologies which we don't have as humans, that we can build into machines that would help the vehicle navigate and find its way around the field and see things that we don't see as humans. Is that something that you've been developing within FarmScan?
We've been looking at it. So it's not that sensor technology is not an area that we're really pushing into, but to be in the autonomous space, you need to have an understanding and awareness of what you can and can't do in the field, because we all have the same challenges. We all need to make sure that safety is accounted for. And for us to provide these systems, we want to make sure that we have the best options available and that they do work in the field. So if we can use a radar, is it impacted by the crop density, and is it actually an effective way of seeing things that are inside the crop, or is it really just information that we can't actually effectively use in the field? And even from a semi-autonomous standpoint, being able to assist with driving and accuracy and things like that, even the auto steer systems, if you're in a really bumpy field, they actually perform better than a human steering easily, because as you're shaking around, it's really hard to keep your hands on the wheel and keep the wheels dead straight. Whereas in general, the electronics don't care about that. They're happy to do it. So they don't actually take a break, and they'll work as hard as you push them. So from that perspective, I think those systems are really important and something that we need to keep looking at, but we're not going to be developing it internally. We just don't have the resources, and there's people like Charles that can solve that for us. So.
Yeah, well, I was going to turn to Charles because, of course, one of the, if you look at your realm of work, Charles, that as we look in the field, then, we can see what's there in the visible spectrum. But the technology that you use, I think, is often multispectral. Could you just talk me through some of the kit that you use, the camera technology that you use?
Yeah, no, sure. Yeah, as you say, humans see in colour. We're seeing three colours: red, green, and blue. So in theory, that is a kind of multispectral. All multispectral means is different colours. We typically use other colours. Humans are very centred around green. That's how we've evolved. So we're very good at telling different tones of green. Great for an agronomist. The problem is that what we aren't very good is tuning how that green changes when there's cloud cover, or in different parts of the country, or even different soil types, changing how that sort of hue of green, a different variety, expresses itself. So that is the challenge. So what we do with our cameras is we put that color of light down ourselves. So it could be teal, could be green, could be near infrared, could be UV, depending on what we're looking to reflect. That light bounces, it comes back, and the camera takes a snapshot, and you work out kind of a signature of, okay, this pest responds in this color or wavelength as we use, and we can choose those around. And what's quite nice about that is you kind of, instead of just having red, green, and blue as we use is a color how we perceive it, we've got this whole other sort of sphere of colors and hues to be able to tune that out. It's quite hard to imagine whenever we sort of try and explain the data to people. You've got like this 3D reconstruction of a plant, but then every single point of that plant, instead of having three colors associated with it, are blended together to make the green or the yellow, the senescence. There's all sorts of others, a whole spectra of colors or of reflectances that gives us quite a lot of information about health, about nutrients, about damage, even about soil content. So there's a huge amount of information that's there. The real trick in agriculture is removing the background from the signal, and that's really what we focus on. And it's kind of shown our story of why we started in breeding glass houses and rolled out more towards polytunnels and now arable, in that we get more and more attuned to it and able to know how to remove it, because it really is quite a sort of onslaught on the sensors for the camera when there's a huge amount of things happening at the same time, and we're really trying to find one or two things out of that. And you go, well, you're on a different soil type, you're on a different system, you're on a different time of day. Is a huge amount. And the speeds of things, Callum's talking about the systems that automate. The reasons why these things are so big and move so fast is we have to cover large amounts of areas. Now, obviously UK farms aren't the biggest, but it's still a sizable amount of to cover, and so the cameras need to be able to keep up with that, and that's no mean thing.
Yeah, no. Well, I mean, one of the interesting aspects there. So I remember hearing about. So it's Blue River Technologies, I think, was the outfit that was bought by John Deere some time ago, and they did a lot of pioneering work in AI and identifying weeds in the field, essentially, I think. And I remember hearing a story about them, in the early days when they were developing it, that they thought they'd got it cracked. They'd been looking in intensive detail at this one field of wheat or where it was, and they reckon that they got it cracked. I don't know, I can't remember whether it was weeds they were looking for or disease or something like that. and they thought, "Yep, no, our system's working really, really well now. So let's just check that it works in the other field right next door." They put it in the other field right next door, and it went completely bonkers. It couldn't identify anything, and it was simply to do. It was a slightly different tone of soil or something like that, and it couldn't tell the background. And I guess that's the thing. So although the AI and the automation and so on is very, very good at seeing everything as you described in different spectrums, it doesn't sort of have our sense of balance, I suppose, or perspective that we have. When we look at a weed in a field, we could recognize it in a field of wheat against this background, and then we look at it in a sandy field or a clay field or a brashy field, we can still identify the same weed. But that's quite a big job for AI to actually manage. Is that, am I along the right lines here?
Yeah, no, exactly right. I mean, it's sort of going into the subset of AI that's machine learning, and really what that is basically learning from experience, seeing a library of known knowns, and then going out and testing that. And as soon as you see something that's outside of that environment, it gets very, very, very confusing. I mean, Blue River, Prospera. There's been quite a few buyouts in the sector. I think they work well in some senses. I think Blue River has always been transplanted crops, so it wouldn't work in anything like row crops in that current setting yet. It was very much looking at things that move, but it was a good, it was an example of a big machinery company moving into that kind of space. So it's an interesting challenge and has been used well and not so well, but by a few. But you can build that in, so there's nothing to say the system can't see what the soil type is, know what its location is, get a lot of that information from the CAN bus on the tractor itself, and so it sets itself in a certain way, saying, right, this is where I know how to operate. And they can learn within reason. You can give them a bit of a leeway to learn. If you give them too much, then they never detect anything because they just see everything as a new normal. It's cameras in themselves. It's really about bandwidth here. Rural connectivity allows you to put more and more capability on those systems, and without it, they become very expensive systems, and that's a challenge. I think that we really.
Yeah, no, absolutely. We'll talk a bit more in part two about how we're applying this technology in the Slimers project. But before I want to break off this conversation, I just want us to sort of look ahead and where this is going. I mean, one interesting fact that we picked up was that if you look at dairying, for example, apparently 10% of the national milk herd is now milked robotically. Which is actually sort of quite significant. I mean, 10% of every bit of milk that we drink or whatever is now done robotically. I mean, that's quite an advance, I'd suggest. I mean, we're nowhere near that in arable. Some time ago, I tried to get a project off the ground, RoboLoaf, which was going to be the first robotically produced loaf. I don't think we're anywhere near that yet. It didn't actually get anywhere. I don't know whether there's anyone else out there who's managed to get that far. But that's the interesting thing. Apparently, more than half of the new systems installed in dairying are robotic. Now, can we expect to see the same thing in arable? Do you think, Callum?
Yeah, I mean, we'd like to, and I think robotics, it's got to play a massive role in the future. It just has to. It kind of makes sense with the way labor's going, technology's moving, alternative power source, that kind of thing. I think one of the things is just arable is so challenging, and it's such a variable environment where everything has to work, harmoniously. You've got so many different machines for different jobs that all behave, very differently, and there's subsets inside of those machines that do different things. That it's training systems to be able to do all that while also being a robot at the same time. There's a heap of agricultural background that has to be put into these systems that they need to do effectively. So I think from the simplistic operations like mowing, some basic tilling, things like that, I think that's a walk-up start, and that's a really good application where we can get into the field and do some really monotonous things, that just jobs that have to get done that end up with a lot of time with bums in seats. I think that's a really effective use. Things where robots are going to struggle is, a lot of the time is with power transfer. So actually getting power into the ground, they're always going to struggle with that until we have alternative power sources. So I think it'll grow, and I'm excited to see where it goes. But yeah, I think it's a good thing to look forward to. And if we got to 10% in the next couple of years, that'd be really impressive. But yeah, there's a long way to go.
Yeah, no, absolutely. Well, we can explore all of that, a lot of that in part 2 of this podcast, and in particular, the challenges with slugs. But before we go, Charles, could I put that to you? I mean, in terms of the big low-hanging fruit, for want of a better term, in arable for AI, where is it, and where are the more challenging aspects, do you think?
Big question. I think automation is definitely there. I think it depends on what we want to call it, because some of us would say some of the machinery that is pulled on the back of a 3-point linkage is very robotic. I think there's huge amounts of hydraulics and electronics going on in a lot of the systems already. For me, I think it's about making the latest sort of already released mass available technology smart. So it's about fitting pieces of equipment like that from FarmScan, like that from 10X, retrofitting a lot of supplementary, a bit like the satellite navigation of cars when you used to stick them on the dashboard, it moved at a different pace. I think that's really where the big wins are. It's about really showing that, and then they will work their way into the major sort of OEM. So for me, it's mostly about integration and not data integration, everyone seems to sort of like, but really about local integration and doing that easily. Because if I want to plug into a John Deere, I've got to pay a huge amount of a license fee, and that's just a huge barrier for SMEs trying to come up with tech opportunities. So there's lots of other ways of incorporating and enabling that, and that makes it cheaper for the farmers. I mean, you mentioned the dairy, the impact of the drop in price of milk made, it caused automation. It just wasn't possible to do that manually anymore. I think that is being seen elsewhere. The problem is that the adoption of technology by farmers is not slow, as it's often called. It's based on a business decision that needs to pay return on investment quickly. So the technology needs to get cheap enough to do that, and that's not easy in this sector. So it's really trying to get the cost of supplying that down and down and down. And that's the real challenge. So that's both the opportunity and challenge as we see it.
Great. And then, well, thank you very much. As I say, we're going to be exploring, both of these areas in more detail in part 2 of this podcast, when we're going to be looking at how we're applying this technology to slimers. Now, just before we go, so as I promised, this podcast attracts CPD points. So if you want to apply for your CPD points, you need to send an email to info@boffin.org.uk with this CPD code. And here's the first part of it. So C for Charlie, P for Papa, 139346. So that's CP Charlie Papa 139346. And then we'll have the second part of that code in the next part of the podcast. So thank you very much to Charles Vase from Photonix. Thank you very much to Callum Chalmers from FarmScam and Ag. And we're going to be coming back shortly with part 2 of this episode, looking at AI and autonomy in arable systems. Thank you very much, and goodbye.